Welcome, students. From this day, we are going to start our lecture series for JEE MAIN 2021. So, this is our first lecture class about the topic set. This is a very rich and very basic topics of mathematics. So this is the main and important tools for JEE main exam. Okay, first of all, we introduce our modern mathematics. Okay, modern mathematics is an online platform for all types of mathematics, for all level of mathematics discussing here. Okay, so through this channel we are going to provide the all type of discussion, all all type of problem solvings through this channel. Okay, I request to all of my dearest students, please subscribe and share. Okay, we have a official Facebook page and official Facebook group, and also we have official Telegram channel. You can join freely to these channels and groups. Okay, through this channel we will provide the practice sets, PDF notes, live classes, and so on. Okay, today we are going to discuss set. So set is nothing but a basic things on, so every topics of higher mathematics, most of the topics depends on the this set. Okay, so we have to understand the set. Okay, familiar clearly and 100% about the to the set. Okay, so I request you, please keep a exercise book and pens. Write down the one liner statement. One liner statements means in for a topics, there are so many one liner statement which are important for MCQ question. That is, every MCQ questions are coming from, are preparing from a sum with from a one liner statement. You have to understand you have to understand that one liner statement. You have to collect all the one liner statement about a topic. Suppose the set we are going to collect the one liner statements of this chapter. Okay, so let's start. You can we can I request you, if you have any queries, you can comment in our comment box and give your valuable feedbacks for our further improvement. Okay, if you want to join our Facebook channel, Facebook groups, Facebook pages, and Telegram or Instagram, so the links are given in the description. So I request you, please join, share, and subscribe. Okay, so let's start. Set. Set. You have to understand there are two words: well defined and collection. Well defined means and well ruled. That is, there is or some rules are there. Okay, the collection of objects as for example, collection of pens, collection of railway tickets. It's somebody has somebody has the as a hobby, as a hobby such as the collection of tickets, collection of keychains, and also, so these are the collection we are going. There is a, but there is a rule. Suppose the ticket maybe some difference of bus ticket, train ticket, railway ticket, or etc. But he collect that only railway ticket. So this is a collection. This is a rule. There is a rule is here. The rule is the ticket all should be from railway. So this is a rule. This is the well defined. This is a well definition of the collection. That means the objects have an well definition. The well definition is a collection of sets. But there is another is also should be there. Also should be there the distinct object. That means the common element, the common identical element is not exist, doesn't exist in the collection. Okay, Okay. So next, the member of this set, the member of this collection is called the element. That is, let X be any set, the object of X or members of X. That is, the tickets, the all the railway tickets of his collection. Okay, that is, we can define a set capital X is that is a collection of all railway tickets by him. Okay, that means suppose we are coming from Howrah to Bardwan, Howrah railway station to Bardwan railway station. In between, there are so many. There are 24. There are so many. There are 24. About 24 railway station are there. So anybody can collect any tickets. So there are no identical ticket are there. There will be the different dated. There will be different railway stoppage are there. So there is no identical, similar or identical objects in his collection. Okay, so the objects must should be the different, and the members of all the tickets is members of the all tickets is called the elements or members of the collection. That is the member of X. If X is the element of capital X, then we say that X belongs to X. That is, if the collection, suppose we collect a ticket. If the collect ticket is a if the ticket is a railway ticket, then this is the member of this collection of his collection. If the ticket is if the ticket is bus ticket, so this is the not member of his collection. So if it is member of his collection, then is denoted by X. This belongs to X. X is belongs to capital X. If X doesn't belong to X, then it should be right X doesn't belongs to X. Okay. So this is a elementary properties, that is the elements, if that with by this definition we are is expressed that it is expressed that the X, every element, if suppose a arbitrary element is a member of this element, then it is denoted by that, and X belongs to X. And it is, if it is not it is not belongs to that, if it may not, if it not the member of, if it not be the member of this set, the collection, it doesn't belongs to the X. Okay, if it is a member of the set, then it belongs to capital X, the set. And if it is not a member of this the collection, this not belongs to the capital X. Okay, so there is a the mathematics is nothing but a playing. What is a play? It's a play with sign. So here we define such a set and its elements. So we have to express it, we have to represent it. So this is a representation. There is a representation. What is the representation? The sets are usually denoted by the capital letters of English alphabet, while the elements are denoted by, in general, by small letters. Okay. A set is represented by a listing all its elements between a bracket and separating them from each other by commas. If there are more than one element, whereas whereas some example sets of are usually notation to use to denote them. That is a set. Suppose the collection of pen. Suppose we say this is a set colored collection. So many colored collections. So this is a set of capital A. Okay. Here in the definition you can see the capital X is any set. Here X is a capital X is a denoting, is representing the set. Okay, and there is an element because small x is belongs to X. So X small x is the element of this set. That is the element of this set is denoted by the small letters, and and sets are usually denoted by capital letters of English alphabets. And if I if we are going to the express the all the elements in the of the set, there is another two different method we are coming the next some second next minute. Okay, so let's some familiar with the let's some examples. There is we have this so many physical the natural examples in our daily life, but we are interested for the only for the mathematical examples and so on. So the set of all natural numbers is denoted by capital N. That is, capital N is equal to 1, 2, 3, 4. What is the natural number? The natural number is after the bond. After bond, we are knowing, we are studied, we are preparing the numbers 1, 2, 3, 4 naturally by a practice. By practice, we have studying, we have realizing the numbers 1, 2, 3, 4, and so on. So these are the these 1, 2, 3, 4, 5, 6 are naturally adopted by us. So this is naturally adapted numbers. So these are called the set of all natural numbers. Okay. So this set is a the collection of all number, the all the uh, mm, pure numbers. So this is called the natural numbers, and is represented here, represented as in the second brackets, and the elements are separated by commas and so on. Okay. And here you can see the set is denoted by capital N. This is the capital alphabet of English, capital letters of English alphabet. Okay. The set of all non-negative integers. What is integers? Integers means we have studied in our previous classes. There are so many types of numericals. There's so many numbers: positive numbers, negative numbers, fractional, irrational, rational. ঠিক আছে? Okay, so these are the set. Non-negative means non-negative integers means 0, 1, 2. That is the set. If the set including with 0 is called the non-negative integers. The set of all non-negative integers is denoted by capital Z with plus, capital Z and uppercase plus is denoted by capital Z uppercase plus is set of all non-negative integers. The elements are the members are the non-negative. Okay. Third example is Z. Capital Z is denoted by set of all integers. What is the space? So the it's including the positive integer and negative integer and 0. Positive integer, negative integer, and also 0. This is called the set of all integers. Is a collection. This is also set. Okay. So this is a set. Okay, with the collection of this is a well-defined collection. We have you can justify the definition of the conditions of the definition for to this example. You can for this example that is the natural numbers. It is there is a rule one increasing order. There is an increase of 1, 2, 3, and the difference between two consecutive numbers is 1. So these are there are the rules. Okay, and is well defined. These are the elements are distinct. There is no two or no any common elements are there. Okay, so these are the sets are these are well defined and well defined collection of numbers. Okay, so Z is denoted by Z is a denote of all integers, and you can you can easily check the condition for this examples and justify your knowledge. Okay. The set of fourth is the set of all rational numbers. Rational number. What is a rational number? What are the rational number? Rational number means P by Q, where P and Q are P is a positive integer, Q is integer, non-zero. Q is a non-zero integers. Okay. Yeah, P is a positive integer and Q is non-zero integers. Okay. So these are called the Q. Okay, capital Q or bold Q. And set of all real numbers, that is there are including positive integer, negative integer, positive number, negative numbers, decimal numbers, rational number, fractional, irrational, and all the types of numbers are included here. The set of all positive rational numbers, if P by Q, where P is a positive integer and Q is a is a positive, Q is also positive, then it's called the positive rational numbers. Okay, and it is denoted by capital Q expressed with plus. Okay, so this is a positive rational numbers. A set of all complex numbers is denoted by capital C, and all the complex number is also just like that C plus A plus IB, where I is the square root of minus 1 is the square root of minus 1. Okay, so there are so many standard types of there are so many types of standard new and standard and standard sets and well and is popular and important sets for our for mathematics. It is very very important, and you can also get you also so many other types of sets in our for the discussion. So going so I'm going next. The preparation of sets. Presentation of sets. A set may be presented with the help of certain property or properties is possessed by all elements or that element of that set. Such a property is a statement which is either true or false. If any objects which doesn't possess this property will not be an element of that set. In order to represent a set by this method, we write between the bracket a variable x which stands for each element of the set. Full stop. Then we write the property or properties. Remarked it properties. There is a single service properties possessed by each element x of the set. We denote this property or properties by px and separate x and px by a symbol is a that is a colon or is a perpendicular line. Okay, read as such that underline read as such that, and thus we write x, that is you can see the here is the set is written in a bracket, and the x is separated by a perpendicular line, and or the colon, and px is the set of statements or the statements. Okay, to present the set of all objects x is x such that the statement px is true, and this presentation of a set is called set builder form representation. That is, that means there are two representation form is there. So that is one is elementary, and there is the set builder method. Okay, where first type is if you want to express the all element explicitly, then this is called the normal, and this if you express the method with the condition, this is called the statement or is the set builder method. Okay, so that is the one is the roster method, and first of is called the roster method, and this is called the set builder method or set builder form. That is, the roster method, the elements are representing the explicitly, that is the here you can see 1 2 4 6 8 10 12 are here, the numbers are said here, the elements of this set can it express clearly. Okay, express represent explicitly. So this is the set, this is a roster method, and if you and here, and if you want to, that is the first example. There is an example, p is the collection of all prime numbers, then it can be represent the set builder form as p. Here p is a set, that is the capital letters of the English alphabet, and x is here x is denoted by the all members, is denoting the all members, all objects of this set. Here the variable stands for each element. It stands for each element. That is uh, x is the all values, all possible values of this of of possible values against this statement. Okay, here is the x is the prime number, x is the prime number, that is x can take the value 1, sorry 1 is, so if you want, if you can write 3 5 7 11 13 17 and so on, these are the roster form. Okay, here here the set is written as the x is and the is in the general form. Here px is the statement. Here px is the statement that x is a prime number. So this is a statement. So there is this is a statement. Oh, so this is a statement. So here the large set, the all the large sets can be expressed in the certain in the by using a statement, and this is called the set builder method. Okay, a set you can write a set you can write either set builder method or raster method or both. Okay, that is here. The P is a collection of all prime numbers. That is, you can, and you have I have write it. I have written it as a set builder method. But you can also write. But you can also write here 2, 3, and for 2, 3, 5, 7, and so on. That is, you can write the elements here also. Elementary method. That is a roster method. So you can, that is, a P can be expressed as a in two forms by using the two forms. Okay. And here the second example is, sorry, this the second example is, here the second example is, x is a set of all positive integers as the which are less than 15. The set of all positive integers is a set of, that means here positive, sorry, all even positive integers less than 15. That is, the numbers here, x is a set of here, I have written it as a set builder form. X such that x is an even integer, and x belongs to 0 between 0 and 15. 0 less than x less than 15. So here the x is an even integer. So 2 4 6 2 4 6 8 10 12 14. So these are the members of this set. So these are the here, in the first line I have written it as a set builder method. That is, the px is a statement that x is an even integer, and there is a one statement, and this is the second statement. There is two properties of this of x. That is, I have in here in the written, we write the property or properties. This is there is a one in the past example. We have seen the x is a prime number. That is a single statement, single condition, single properties. But here the x is an even integer, and 0 less than 0 less than x less than 15. There is a second, there is two conditions are there. That is, the two properties are there. So this is a set of there is a collect two there are two properties are there. So x should be satisfied by x should be satisfied these two properties. That is, the properties should be satisfied by x. These are the values, satisfying the conditions, satisfying the properties of this set. 2 4 6 8 10 12 or 12 15, 12 14. So these are the members of this set. So this is a set. Okay. So here there's so many types of examples are there. So so many types of set are there. So we have to collect, we have to know the sets, because in further studying of the different topics, and and rich topics such as relation, function, and also calculus is also based on the set. And you can also get the set theory on probability. Probability is probability mostly based on the set theory. So set theory is a common basic knowledge, common basic tools for our mathematics, for the higher mathematics. So you have to know the sets in any one liners. You have to collect the one liner statement, such as here we can see in my presentation. There is some sort of collection in the short line, but there is a huge description. So there is a huge there in every word I have discussed, and I have discussed a large number. I have spent large number of large words. So I request you all, please note down the all one line statement, and also notify, and also mark on your exercise book. If you want to the this PDF, and if you want to technical assistance, you'll get the PDF. Okay. And I request you, all of my dearest hard students, please share with your friends and known person to familiar with this channel. And also, the if you want to if you want to join our classes, and also if you want to get online practice, online notes, and also we are going to arrange online mock test, free mock test. Please join our YouTube channel, and also Facebook group, and Facebook page. So till now you will get, you if you if after joining, you will get some lots of practices, lots of workout examples are there in our Facebook page. please join fast. So there are also so many PDF notes are there. So I request you, please join and join, share and subscribe. So now we are going to start our study. So come back. There is empty set. There's so many types of sets. That is sub of empty set. What is empty set? Empty means backward. Empty set is also known as void set or null set. That is, there are so many names are there. Like as Krishna Ashtottara Shatanam, uh, 108 names of Lord Krishna. Such as here also is there. Here or null set or backward set. Okay, empty set means there are no elements are there. There is a set, but there is no element are there. Is there? So this is a empty set. Is there? Nandi, I request you who is please sir. Yes, Nandi, please tell me your full name. So there is a this is a empty set. What is empty set? Empty set means there is no elements, but there is this. Suppose the integers between there is positive integers between 1 and 2, but there is no positive integer between 1 and 2. So there is, if you define a set capital A, if you want to define a capital set capital A such that capital A such that there is that second bracket x such that x is a positive integer between 1 and 2. So there is no elements are there. There is no element are there. So this is a backward set, this is a void set, or this is a null set, and is called also empty set. Okay. Two sets. Please share with your friends uh, and knowing persons who are interested in higher mathematics, and also those who are preparing for JEE Main and also JEE Advanced. Okay, and follow our channels. So these are the this is a empty set, and this is so we are coming to a study. So equal set means there are two. Suppose there are two sets and B. When it is called equal set, when it is called equal set, there is a when two sets are equal, there is the same number of elements are there, and also the elements are in common. The all elements are in common. Suppose suppose a set capital A is ABC, and capital B is a set where is included ABC. These are the set are called equal set, because there is three elements, and the B also including the three number of elements of B is also three, and the elements are also should be same. That is the for the equality of the two sets. So there is two condition. One is the number of elements of the two sets are equal and should be equal, and also the elements should be common. All the elements are in common. Okay, so then these sets are called equal set. Okay, there is a next important is a finite set and infinite set. This is the number of finite and infinite sets depends on our classify. This is a classification of classification of a set according the number of the elements, according the number of the elements of this set of a set. A set having a definite number of elements is called the finite set. A set which is not finite is called infinite. That means there is a, if you can choose an set from mathematics. Suppose a natural number. There is a natural number. There is a infinite number of elements. If a set if you have a infinite number of elements, this is an infinite set. If there is a finite number of elements, if there is a finite set. Okay. So the number according to the number of elements of the set, we can classify the set in two. Okay, finite set or infinite set. Okay, as for example, in our we can go with this set, the set of the x is a even integer, and also 0 less than x less than 15. There is only seven numbers. There is a finite set, there is a seven number, but for the first example, p is x is the prime number, there is an infinite number of value. This is the p is the infinite set, and here x is a finite set. Okay, the family of sets, the very very important topics, very very important notes are there, is their family of sets. That means this is also called the set of sets. This is also called the set of sets. Very very important, you can mark it, you have to mark it here. So a set whose members are also sets is called the family of sets, or class of sets. This is also called the set of sets. It is also called the set of sets. Set of set means, suppose you have a set. Suppose you have a set, you have collected so many, you have defined so many sets. You have defined so many sets, then you can collect it in another set. So this is called the set of set. Suppose if one can the one set second, and there is a number of n, that is you can collect capital N is a natural number set, capital Q is a rational number set, capital R is a real number set, capital C, and this is a complex number. You can include in a second bracket, you can collect it in a second bracket. This is also set, where the elements are capital N, capital A is the natural number set are there, and real rational number set are there, and real number set and complex number set are there. So these are the set of sets. Okay, I forget it, that the finite number of a finite set are also there are so many collections, that is a singleton set. There is a singleton set. The singleton set means there is, if we set, if is a one is only a one element, these are called the singleton set. These are called the singleton set. Okay, so that is the next is the intervals of order. We are familiar with the intervals. Interval is nothing but a subset of set of rational numbers. So many set of rational. That is the interval means A is here is denoted by, okay, is a standard notation. First bracket of that those elements which are real numbers, and this lies between A and B. But X doesn't assume A and B. X doesn't assume A and B. There is a an elements. There is a uh, so this is a interval. This is called the open interval. And second is A is open but B is closed. Here this set is also containing the elements which are between A and B. But here X is assume B but doesn't assume A. And second is also X can assume the value A, and X can assume the value B. And there is the X is the real number between A and B, and X is also assume, X can assume A and B. Okay, so these are the set. And this is interval, that is the intervals inner is also a set. There is interval of set. Then these are the finite or infinite. These are infinite set, because any two real numbers, there are infinite number of real numbers are there. In between two real numbers, there are infinite number of real numbers are there. So this is the infinite set. These are the infinite set. Okay, so next there is the set operation. That is set here. Set is a new at a new there is a set is a new our knowledge new at a new topic. So we have to, there is a operation. That is operation means the plus. There is addition, subtraction, multiplication. These are the operation. Also here set is the in set there is so many operations. Then we have studied that is two operations. Those two sets are there. Also there is some operation or set. We can operate there, operate those sets. How to handle the two sets. How to categorize, how to separate, how to judge the sets. There is some operations are there. So for any two sets A and B, we say that A is a subset of B, or A is contained in B if every element of A is an element of B. In this case, we denote it by A subset B. This is called the subset sign. This is a subset sign. Okay, that is the if every element say that is A is a subset of B. That means the A is a subset. That is A is smaller than B. Smaller means the number of element of A is less or equal to number of element of B. But there is one most condition is the element of B is also the every element of A is also an element of B. The every element of A is also in B. Okay. So this is then is called then A is called subset of B, and B is called superset of B. B is called superset of A. Okay. Okay. So power set, you can say some so many examples. Suppose there is a set capital P such that P is a set of all collection between 1 and 10. There is 1 2 3 for all positive in all integers 1 2 3 4 5 6 7 8 9 10. And Q is another set 1 2 3 4 5. So there is two set P 1 to 10 and Q is 1 to 5. Okay, so every element of Q is also the element of P. So Q is a subset of P, and P is a superset of Q. Next is power set. What is a power set? This is a power set means the for any set capital X, the collection of all sets of X is also a set and is called the power set of X, and it is denoted by Px. P of X. That means the set of, suppose you have a set, you can you can define so many sets, so many subsets of this set. In just few seconds ago, we have learned subsets. So if from a set you can define so many subsets of so many subsets. The possible all type of subsets, all the collection of all subsets of a set is called collection of all is called the power set. Okay, this is a very important topics. And the cardinality, mark it in with red color. Mark it cardinality, mark it with red color. In J for the J main, the cardinality is a very important part from the set, from this chapter, because there are so many examples there are so many examples coming from cardinality. If X is finite set, then the number of elements in X is denoted by mod, that is called the mod X, or it has small x when small n of capital X, and this number is called cardinality. Okay, this is called the cardinality. If X is finite set, then a mod X or capital N is also finite. If X is infinite set, then it is called cardinality 0. Then it is called the cardinality 0. Okay. If suppose the cardinality 0 means the 0 element, or is called the infinite set. Okay. Okay. So if X is finite, then mod X and Pn is also finite. You can justify the cardinality for the subsets. For X, the if suppose you can subset is proper, there is subset two types of proper subset or only subset. Proper subset, for the proper set, the sign is should be without this line, without this equality, with this equality sign. The one is single line is called the equality. So for proper subset, equality is not there. Okay. So for the proper subset, there is at least one element in B such that which is not in A. There is one list one element in for the proper subset. If A is a proper subset of B, that means that at least one element of B which is not in A, then mod of A, that is cardinality of A is strictly less than the cardinality of B. Okay. If it is not a proper subset, then the cardinality of A is less or equal to the cardinality of B. Okay. So this is a one liner statement. Okay. This is a one liner statement. You have to notify it. You have to write it. Okay. That means from a definition or from so many statement, you have to conclude so many you have to understand the so many conclusions, so many corollaries, which are very important for MCQ. Okay, for MCQ question. So for a subset A is a proper subset of B, then the cardinality of B, then the cardinality of B is less than, is strictly less than the cardinality of B. But if A is not a proper subset, A is only a subset of B, then the cardinality of A is less or equal to the cardinality of B. Okay. So coming to the next, the very important theorem. The if let X be any subset, is any set, and then X is a finite set with n elements. If and only the power set Px is a finite set with 2n elements. Sorry, 2 to the power n elements. Sorry, here is written in the middle set 2 to the power n elements. Okay, that is F is a finite set. If F is a finite set with n elements, suppose n has X has a 10 elements, then the number of power set means the set of all set of all subsets of capital X. Set of all subsets of capital X is called the Px, that is the power set of X. So with L number, the is 2 to the power n, is 2 to the power n. Okay, this is a very one liner statement. Okay, corollary. If for any, if this corollary very important, very important, the cardinality for any set capital X, mod cardinality of X is less than, there is a strictly less. Why strictly less than? You have to here you have to justify it. Here you have to notify it. Here you have to clear it. Okay. Here cardinality of capital X is less than, is strictly less than the cardinality of the power set of the X capital X. Why strictly less than? We have to find the answer of the why, of this why. You have to understand, this is the MCQ question. This is the why. Because if suppose you have a, if A has a only X, if X is a singleton set, that is there is one element. So P of X is phi and also singleton. So there is two element, at least one element. There is a two element in power set. Okay. So this is the, so there this is the strictly less. But when it is equal, when anytime is it equal? Yes. If X is phi, that is X is void. The only singleton, there is also singleton then. But for any finite set, that means this is there is at least one singleton element is there in capital X. That is there is a one, at least one element in capital X. Then the corollary is satisfied. Okay. Now come to the next operation, intersection of two sets. Intersection of two sets. For any two sets A and B, we define the intersection of A and capital B to be the set of all elements belonging to both A and B, and it is denoted by A intersection B. A intersection B equal to capital X, that is here written as is a set builder method. That is A is A and B, intersection of A and B is mean by, is mean that, is mean that the common element, the collection, this is also a set. The intersection of two sets is also a set which containing the all common elements of this set, all common elements of this set A and B. Here I have written it. A intersection B is X such that X is also is the element of A and also X is only element of B. So this is the main theory. This is the main important. X is common A and B, A and B. So this is the intersection of sets, of two sets. Okay. And intersection is also a binary operation. Why? At one times, but by an one operator, one intersection sign, you can operate two set at a time, two set at a time, not more than two. So this is a binary set. This is a binary operation. We can't go. We can in our discussion relation. We can we can discuss. We have to discuss the binary operation. So coming to the next and last slides, and the today's the last lectures, and I have come to the last at last. And if you have queries, you can ask. So now some examples, examples of some examples of two examples of intersection. There is a is a set here. Here is a set and here is a b, and there is a common 7, 11, 13, 17, and 19. Because a here you can see here a is a finite set and b is a infinite. Here is a dot 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 means the number is going on. So 12 and so many on 7, 9, 9, 10, 11, 12, 13, 14, 15, and so on. So there is so here also the difference. There is a rule here. There is a rule one by one increasing, and here is a rule is two increasing. So there is a here a is a finite set, b is infinite set, and after intersection, after taking intersection between a and b, so you will get 7, 11, 13, 17, and 19. Okay, so this is the intersection, and from this set, then that is we have conclude that the intersection of two sets is also a intersection of two set is also is also a is also a set. So it may be finite or infinite, and it may be empty. If the intersection is empty, then it is called the disjoint set. That is intersection of two sets. That is the this is also a set. It may be empty. In our if the set is empty, then it is called disjoint set. Then it is called the disjoint set. Okay. So in this case, we say that A is disjoint with B or B is disjoint with A. The next operation is union of the sets. Union of the sets is union is the set is the this is also the collection of all elements of A and B. All elements of A and B. Okay, but the common but the common elements of A and B of the of these two sets are taken as one times taken as one times. Okay, here if you intersectioning the A and B here in this example 7, 11, 13, 17, 19 were take is that one time as one time. Okay, that is the union of the which and those elements which are in A but not in B, and those elements which are in B but not in A. And these three type of elements is in a collection, then is called the union of A and B. And this is the union of two sets. And union is also the binary operator because at by one single union sign you can operate, you can union the A and B or two, that is two sets only, two sets at a time. So this is a binary operation. Okay, I request you all, please here the studying all the if you have any queries you can ask through our comment chat box and also comment box and through our Facebook group. And if you want to mock test, so please you can join our Facebook group. Okay, and also Telegram channel which is named as JEE Main Modern Mathematics. Okay, so I request you all, please share, subscribe. Okay, and also if you want to if you want to the if you want to all if you want to any notes about JEE Main for mathematics, I will provide you at free of cost. Okay,